Set up but do not evaluate an integral that represents the length of the curve. Here we're given that x is equal to t, y is equal to t to the fifth over 10 plus 1 over 6t cubed, where t runs between 1 and 2. To find the length of the curve represented by these parametric equations, we of course use the arc length formula for the parameterized curve. So the integral from a to b, the square root dx dt squared plus dy dt squared dt. We know that our limits of integration, a and b, are 1 and 2 respectively. Those are the endpoints of the interval. So we merely need to find dx dt and dy dt. We can do that from our equations, our parametric equations given. So x is equal to t. Just rewrite it so we have it there close. Y is equal to, this is the same as 1/10 t to the fifth. Plus, we might as well rewrite the function 1/6 t to the negative 3, just to make it easier to find the derivative. So dx dt is the derivative of x with respect to t. Here that's 1. And dy dt is 1/10 times 5t to the fourth plus 1/6 times negative 3t to the negative 4. Of course, dx dt is just 1, nothing to do there. But we could simplify dy dt a little. Namely, this 5 will go into the 10 2 times. The negative 3 will go into the 6, and we'll be left with a negative 2 in the denominator. So we'll have 1/2 t to the fourth minus 1/2. Well, really, the negative exponent of this t will drop that factor of t into the denominator. So really, t to the fourth. So now we have dx dt, dy dt, and remember that our limits of integration were given in the problem from 1 to 2. So our arc length is the integral from 1 to 2, square root dx dt squared, so 1 squared, plus dy dt squared, 1/2 t to the fourth minus 1 over 2 t to the fourth squared dt. Here's our integral, which represents the length of the curve on the interval from 1 to 2.